Hello students, today we'll talk about gas laws and in particular we'll start with Boyle's law. So Boyle's law gives an empirical relationship between pressure and volume. So according to this law, at a fixed or a constant temperature, fixed mass of a gas, fixed mass of a gas. So these two things you must remember. Number one point is at a constant temperature. So what do you mean by this? Look at this carefully. We have three entities: pressure, volume and temperature. And these three will define the state of a system. We all know that a system is basically a part of the universe which is under observation. So now the thing is, PVT, to define the state of a system, we need the help of these three things. And to understand the interrelationship between any of these two, we have to keep constant the other one. That means if you want to study the relationship between pressure and volume, then the temperature must be constant. If you want to study that interrelationship between volume and temperature, then the pressure will remain constant. So on the basis of these concepts, Boyles is actually establishes a relationship between pressure and volume. And according to this law, pressure is inversely proportional to volume at constant temperature. Del T will be 0. So now we can actually write it like this, where K is my constant of proportionality. Now this K will depend upon, like we said, at constant temperature and mass. So K will be dependent on amount and temperature. So K will be dependent upon temperature and amount, and that too directly. So now this is what the empirical relation is between pressure and volume. And let me tell you, these are limitations law. That means Boyle's law, Charles law, all these are limitation law. That depends under the certain conditions, certain limitation that is applicable on the under certain condition. So now we can write it like this: PV is equal to K. That means PV is equal to constant. So P1 V1 is equal to P2 V2. And why is it so? Because PV is constant. P1 V1 will be equal to constant, will be equal to P2 V2 will be equal to constant. Now the next thing is, you must know how to draw graphs. So first of all, as we know, this is the interrelation. P is equal to K by V. Fine, K by V. So P is K into 1 by V. Y is equal to mx plus c. We can apply this. So we can take P, Y, 1 by V, x, and K is going to be my slope. Positive slope. Fine. So this is going to be my graph, straight line. What about the next sort of a graph? PV versus P or PV versus V. As it is evident that PV is equal to constant, we may say, like, you can take an example, 6 into 4 is equal to 24. So if you increase this one, this will become 8 and this will become 3. The result will be same, 24. Fine. So 8 into 3, that means if you increase this quantity, this will decreases, keeping the whole value constant. So PV versus P again give you a straight line. Same is the case with this. Fine, pretty easy to understand. Now what we want next? We have done with P1 by V, P versus 1 by V, PV versus P. Now let's talk about P versus V. Simply as it is, Y versus 1 by X sort of thing, and P versus V, because we all know that P is this. So at very high volume, the pressure will be minimum. This is what the relation is. But again, mind it, temperature will be constant at each point of this, at each point of this, at each point of this line. So all these are known as isotherms. Isotherms means temperature will remain constant. Isotherm. Fine. We have these three what we can say names and terms, like isotherms where temperature remains constant, iso means same, isobar where pressure remains constant, and isochore when volume remains constant. Fine, my dear students. So now next, maybe ask, draw a graph. Fine. So as we know that PV is equal to K, take log P plus log V is equal to log K. Fine. But now we need this one as on y-axis and this one is on x-axis for say. So log P is equal to minus log V plus log K, y is equal to mx plus c. Fine. So the graph will be like this with the negative slope. Okay, we can draw it on on next page. Log P, log V with a negative slope. Clear? So this is how we can understand Boyle's law, with one more pretty important consequence. My dear student, it is quite evident that by increasing pressure, we can reduce volume. It shows that gases are compressible. Fine? Okay. If gases are compressible, let's talk about their density. Is there is any relationship between pressure or density? Because once we compress a gas, keeping the mass constant, the volume decreases. So by this means, the density will certainly increases. So now let's take a thing out of the Boyle's law. And we all know that pressure is K by V. So V will be K by P. Put it here in the formula of density. So D is equal to M by K by P. So then P will be on this side. So mass in this thing will be constant. So pressure is directly proportional to density. So this is the main consequence of Boyle's law. Okay guys, so this is in a nutshell, this is all about Boyle's law. As I was observing that actually you are not devoting the complete time as far as the long lectures are concerned, so I am just confining myself in these videos, topic wise videos, so that you can watch, you can learn in a very limited time. Okay, all the best students. Next lecture will be on Charles law.